Hi, and welcome to part 2 of our Flow360 training. Looking at our expanded visualization of the training structure, you can see this session will provide an overview of the web user interface. For today's introduction training, we'll cover 6 topics, starting with an overview of the web UI dashboard. Next, we will look into the details of Workspace, projects, and Workbench. Then we will cover how to set up a case from a geometry and a mesh. Next, we will discuss the Analysis tab, which covers all simulation visualization. Afterwards, we will discuss how to compare cases. Finally, we will wrap the training up covering miscellaneous features that can be of value. Now, starting with the dashboard overview. When you open the web UI of Flow360, it will start from the dashboard. This provides an intuitive overview of items of importance, including recent projects, flex credit balance, the status of all projects, and quick links to example simulations. Each project within the Recent Projects section shows what entities exist for each project. For example, this case has a surface mesh, a volume mesh, and one case run. You can easily open a recent project to access all entities. At the top ribbon, you can change your view to open My Workspaces or the full example library available. The My Workspace tab is like a local directory where you can create a folder structure to store and organize all of your projects. At the top left, you can click the plus icon to create a new folder and add necessary tags, which helps with searchability. Once that folder is created, projects can be moved to that folder, or a new project can be created. You can switch between Project View and File View. Project View shows everything grouped by project. File View shows individual entities such as geometry, surface mesh, volume mesh, and cases across all projects. Every entity in Flow360 has a unique ID, even if 2 entities have the same name. This is how the system uniquely identifies everything. Folders also have IDs. These IDs are important when using the Python API. For example, to download results from a case using the Python API, you only need the case ID. To submit a new case on an existing volume mesh, you only need the volume mesh ID or project ID. Now, going back to the top ribbon, in the top right, you will see a question mark icon. When you click this, it opens a quick link panel to access important and relevant support information. This includes the web UI documentation, and it also includes the link to the full documentation provided in the previous training. Release notes that are updated every couple of months to cover solver improvements, bug fixes, meshing, post-processing, and Python API changes. And access to submit a technical support request. Next to the question mark icon is where you can access your account information. This is where you can adjust your preferences, see flex credit transactions, including storage and simulation costs, view your Python API key, and turn on multi-factor authentication. One final item to be aware of is the search bar. You can use this to search for IDs, projects, keywords, and more across your whole workspace or a specific folder that you are in. Now we will walk through how to create a new project. To start, click the New Project button. This will open a panel where you can add a project name, select the solver version, adjust the units of your geometry or mesh, add a description and tags, and then select the method for creating the project, which can be started from a geometry, surface mesh, or volume mesh, and finally drag and drop or browse for your file and click Submit. When a project is created, each stage of the simulation is saved into a project tree. To open the project tree, go to the top navigation bar and click on the project name. This is a hierarchical visualization which provides an intuitive way to view, track, and navigate to different stages of your workflow from geometry to final results. Each component can be expanded or collapsed using the drop-down arrow at the bottom of that stage. Clicking on a component opens a menu with different options, including opening the component in the workbench, copying the setup to a new simulation run, and editing the name or tags of the component. If you open a solved case in the workbench view, you will notice that when you try to edit the simulation setup, the options will be grayed out because that simulation was already completed. If you want to use the same simulation settings, you can click the New Run button at the top right of the interface, which creates an editable draft. All drafts are saved at the top of the project tree view. Now let's go back to the workbench to provide an overview of the interface. The workbench consists of a viewer region, the simulation setup and analysis panel, the entities browser, the coordinate system, a top navigation bar, a bottom status bar, and a viewer bar. We'll walk through the details of each key element. The viewer region is where the geometry, mesh, and simulation results are displayed. You can directly interact with the model here using different mouse and wheel controls as listed on this slide and in the documentation. Next is the Entities panel that has all information of entities in the project. You can view geometry statistics by clicking the Information button next to the geometry entity. You can also hide, view, edit, or create new entities in this panel as well. For example, you can hover over different entities to highlight where they are, create a new volume in the domain, or adjust the environment background, lighting, and rendering. The status bar at the bottom shows simulation progress and status. Clicking the Inspector tab will perform a validation test on your case and show any warnings that need to be addressed to continue. Clicking Run Status will show you a progress log of each step within the full simulation. The top navigation bar is used to view the project tree or other quick actions like documentation, release notes, and technical support. Here's where you can also access all project assets to download files from each stage in the project. Nested under the navigation bar is the viewer bar, which allows you to switch between different view modes like geometry, mesh, and post-processing, or switch model selection methods like points, edges, and faces. The Simulation and Analysis tabs are on the left side of the screen. Starting with the Simulation tab, this is where you apply all meshing and solver inputs for your simulation. Flow360 automates a lot of the meshing and setup by providing default values and selections to help reduce the amount of work required for the user. The Analysis tab is where you can view convergence and monitor plots as they update in real time. This is also where post-processing visualization is performed. We will quickly walk through the general workflow steps when using the web interface, and then go into an end-to-end demonstration. We'll start with the meshing and simulation setup, then verify everything is ready using the inspector, initiate the run, track and monitor the progress in real time, and finally visualize the results. Now let's start the demonstration. We will start by creating a new project using the New Project button. In the panel, we'll add our project name, use the default latest public release solver version, keep the units as is, and then add a description for this project. You'll notice when I hover over the Browse button to upload the model, a pop-up appears that shows all supported file formats. For this demonstration, we will start with geometry. I'll select my model and click Submit. Once uploaded and converted, I'm notified the project has been created successfully. Clicking the project card opens the workbench. We'll start from the Simulation Control panel on the left sidebar. First, we will define the operating conditions by clicking on the text to open up the Setup panel. We will adjust the velocity, magnitude, and alpha angle. Next, we will define the far field. We'll use Flow360's automated far field option, which determines and creates the appropriate far field dimensions based on the geometry, which is automatically created at 100 times the model's maximum dimension. If you have your own far field geometry, then you can select the user-defined option. As we progress through the steps, you will notice there are tasks with a red dot on the left side of them. This means that there are warnings that need to be addressed before the mesh or the simulation can be submitted for running. As we mentioned earlier, you can see additional details on all warnings by opening the inspector window from the bottom of the interface. These warnings will be cleared as we complete the incomplete parameters of the meshing and simulation setup. We'll move on to the mesh parameters. Flow360 uses an automated meshing process that reduces the amount of work required for the user by providing default values that are sufficient to generate a high-quality mesh for most cases. As you can see here, we only have to provide a surface max edge length and first layer boundary layer thickness. Advanced parameters are available, but not needed for this model, as the default values will create a good enough mesh for this demonstration. The next step in the process is to add mesh refinements. Before adding in a refinement, we are going to create a near-field refinement zone using the Entities panel on the right side of the screen. In the Volume section, click the Add button and select Box. This will open the Box Editing panel, where you can adjust the location and size of the box. You will notice that edits can be viewed in real time in the Viewer region of the interface. You can adjust the model view to visually confirm your box dimensions are sized as expected. After that, we are going to add a mesh refinement to the box we just created by clicking the Add button next to Refinements and selecting Uniform Refinement. The mesh is ready to be generated, which is done by clicking the Run button in the top right of the interface. You can generate just the surface mesh if preferred, but we will generate this up to the volume mesh. Once completed, mesh metrics can be viewed using the Metrics Cell button in the top left corner of the Viewer region to view total nodes and the quantity of different mesh cell types. You can also expand the metrics to see the mesh distribution across different boundaries, evaluate aspect ratio in different volumes, and other general evaluation and debugging. Now that the meshing is complete, we can finish the setup of this model. You will notice that Flow360 automates a lot of the setup for you to help reduce the amount of work required. For the boundary conditions, all surfaces were automatically assigned as no-slip walls. A variety of boundary conditions are supported, as you can see here. The far field was automatically created and assigned to the free stream, and using the operating conditions we applied at the start of the simulation. Flow360 supports both steady and unsteady. For this case, time stepping is automatically set to steady for 2,000 steps. Advanced settings are available if needed by expanding each section in the panel. Under Physics, we will open the Fluid panel to review the solver settings. In terms of modeling turbulence, Flow360 has the SA and K omega SST turbulence models, along with RC and QCR corrections. For modeling flow transition, Flow360 also supports the amplification factor transport model. The Navier-Stokes solver and initial condition setting will be left at default, but each section in this panel has a variety of advanced settings you can adjust when expanded. The final step before solving is to set the reference dimensions, which will be used for non-dimensionalizing lift, drag, and other forces and moments to get the force and moment coefficients. The simulation is now ready to solve. While Flow360 does automatically create a list of surface and slice outputs to generate during the simulation, this is the time any additional outputs you would like to evaluate should be added. This includes data like volume, surface, point monitor, and streamline outputs. We won't add any additional for this, so at this point we are good to solve by repeating the run steps we did earlier when generating the volume mesh. Clicking Run sends the simulation to Flexcompute's own GPU cluster, powered by the latest high-performance GPUs. The job is instantly picked up and assigned to the optimal quantity of GPUs based on the size of the mesh. As the simulation is being solved, your view will automatically shift to the Analysis Dashboard window to show real-time convergence of residuals and forces. Scrolling from top to bottom, the residuals monitor is displayed at the top, showing real-time convergence history. Below that is the statistical data averaged over the last 10% of pseudo steps for lift, drag, force, and moment coefficients, and their respective interactive plots. Each of these can also be viewed individually by clicking the corresponding section on the control panel on the left. To visualize results, we can close the dashboard window. We'll hide the volume box to get a better view of the aircraft. In the same Entities panel, you can expand the post-processing section and show or hide different results, such as surface output, slice output, ISO surfaces, and streamlines. For more advanced customization of the results, you can go back to the control panel and select a result. This will open a corresponding panel, where you can adjust the color map, value ranges, and result variables. Multiple components can be shown at one time. In this example, we have a variety of outputs for the surfaces of the aircraft, clips through each major axis, and ISO surfaces. All data generated throughout the full workflow is available to download and share by clicking the Assets cube icon at the top right of the UI. Data from all stages can be downloaded, including the geometry, surface, and volume mesh, and simulation results. Visualization results can be downloaded as a tarball to be used for further post-processing. If you would like to compare multiple cases that you have solved, you can do this by going back to the project tree. Here we have already run an alpha sweep for this geometry. Hover over a case and then check the box on the left. As you select multiple cases, a panel will appear at the bottom of the screen with the option to compare. Within the case comparison, you see that CL versus alpha curve directly pops up. You can change it to other forces as well. Also, you can compare the convergence history of residuals, all forces, and moments as well. That concludes the demo portion of this training. Before we wrap up, we will run through some frequently asked questions and then provide some miscellaneous tips to help you be even more productive with Flow360. One important item to know is the view-only version of a project. Once a case is solved, editing access will be removed, and you must create a new draft of this setup before you can edit. This is done by clicking the New Run button in the top right of the interface. Another important aspect is how to fork a case. You would use this option if you have already run a case and you want to continue the solution, or make changes and use these results for initialization. A simple example would be to use a completed simulation at one alpha angle to initialize a different higher alpha angle. This can be done from the workbench view by clicking the Fork button to the left of the New Run button, or from the project tree by single-clicking the case and selecting Fork. One more useful feature is related to reusing an existing case setup through JSON files in the web interface. You can export a JSON file by going to the top navigation bar and clicking the ellipsis button and selecting Export Settings to File. You can customize which setting you want to export, and it will automatically create a JSON file you can adjust and re-upload to a different project in the web interface to automatically set up similar parameters for a new project. The next handy feature is viewpoints. If you want to save a custom view within the web interface that you can go back to at a later time, you can do this by going to the Viewpoints entity in the Entities panel and adding a new viewpoint and assigning it a name. Now, to conclude our training, I will provide you with a few miscellaneous tips. When you submit cases through the Python API, they can also be viewed in the web interface, and the opposite works, where you can download results from cases created in the web interface using the Python API. Another tip is that cases can be submitted while surface or volume meshing is still being generated. Similarly, you can also fork cases before the parent case is finished solving. This is helpful for alpha sweeps where the cases will continue to run, so you do not have to come back and fork the case after the run is complete. The final tip is that you can go to the Analysis tab before everything with the visualization is complete. This means that as your case is still solving or preparing the post-processing visualization, you can open the Analysis tab and view convergence or monitors in real time. With that, we have now concluded the second training session on the web user interface. As you continue your onboarding, we recommend that you use and reference the Quick Start Guide available in our documentation. We would also appreciate to hear your thoughts and feedback so we can continue to make improvements and shape the development of Flow360.